So dear student, today we will be going through the Thevenins analysis. Okay. So I'll be just sharing you the PDF. Yeah. So this is the Thevenins theorem. Okay. So as you can see here, a large and complicated linear circuit like this, correct? So it is just replaced with what? RTH, that is Thevenin's resistance and load resistance. That's it. So how much ever resistance are there, you'll be just replacing with just these two things. This is equivalent resistance. Okay. You can find here VTH, right? Correct. So we have to find VTH, that is voltage Thevenins, and RTH is resistance of Thevenins. So first thing is what? To find the steps. So very, very important. Sometimes they will ask you what is the Thevenins theorem, but I hope you understood what it is. But the examination, we have to write it as it is, then we will get the full marks. Now coming to Thevenins voltage and Thevenins resistance. First thing is we have to remove what? The load resistance to find what? RTH. This is just to find what? The RTH. Sorry, to find the VTH, the voltage Thevenins. Correct. We have to remove what? The load resistance. Okay. And mark the voltage across the open load terminals and designate as VTH. In the sense, if I want to just show you this diagram, this is my load resistance. This I will open it. Okay. And that's called my VTH. See, just like opening the circuit and short circuiting, I'll tell you what is the basic thing. Okay. So a lot of people still have doubts what is open circuit and short circuit. It's a very simple thing. Just take a real life scenario. Okay. The tap. Okay. So if you open the tap, the water will flow through it, right? Correct or not? But if you close the tap, what will happen? Will the water flow? No. So which means very high resistance. It's holding the water. Correct? So open circuit is nothing but what happens if the tap is closed, correct, water is not flowing, which means treat water as current. So current is zero. Current is zero. It's holding the water, right? So high resistance. So like that. And also in a lot of movies you might have seen due to short circuit, there has been blast and everything, no? Correct? So current is all about what? Power. So if the water tap is open, then what will happen? The water will be flowing, right? Uninterruptedly. That is the scenario for short circuit. In the sense, there is nothing to hold the water. There is no resistance, zero resistance. Then current will be what? Maximum. Clear? So these are the two things. I will tell you. Thevenins theorem. So yeah, to find VTH. So I hope you understood what is open circuit and short circuit. Yeah. Then just by using KVL or any other measure, simple series and parallel, whatever it is, you can find. So to find the RTH also, okay, remove all the load resistance. So first step is same. Then replace all the independent voltage sources with short circuit. Voltage sources with short circuit, straight line. So maximum current or uninterrupted current. And all independent current sources with open circuit. Open circuit I just showed you. Then looking at the open load terminals, find the equivalent resistance. It's very simple only. Pretty much simple. So let's see this thing, the numerical, using Thevenins theorem. So calculate the current flowing through resistance R and varies between 6 ohm and 36 ohm. Okay, fine. So let's take this 60-30. Correct. First step is what? Remove the load resistance and make it open and replace it with VTH. We did that. Yes. Now, as you can see here, 90-60-30 makes a simple series path. Okay, so if you 90 volt, this whole thing makes a simple series path. and another 100, 40 and 60. So here, since it open circuit, what is it? Current is 0. So we can ignore this junction completely. We can ignore this part and this part also. Open means current value is 0. Okay, and if you take this junction, current can flow in what? Two direction. Entering 2, exiting 2. Here also entering 2, exiting 2. Okay, so if it is less than 3 flows, the current can flow. It is said to be in what? Series. Okay, and once we do that, 60 plus 30 is what? 90. And here also, what is it? 40 plus 60, 100. So I can find the two currents. Very easy. I is equal to V by R formula. I want need to found out. Correct? Now you can see here the KVL apply. DAB CD. DAB CD. This part. DAB CD. To find what? The RTH. Correct? So DAB CD. And then how to find it? So I'll just erase everything. Then I'll show you. Just mark everything. Okay. So if I want to take, I'll take this in clockwise direction. So put minus plus. Then here also you put what? The current entering, right? Yeah. It is going through this plus, minus plus, and here it is what? 60 ohms is there, and here it is what? 30. So put here plus, minus, yeah. And then again it is going here. Entering is plus, leaving is minus. Yeah. So that's it. So coming to this, I'll start with this minus to plus. Minus to plus, voltage rise. Plus to minus, voltage decrease. So minus to plus, plus 50 volt. Correct? And VTH is what? Plus to minus, already given. Plus to minus. Minus VTH, done. Then plus to minus. What is my voltage? Current and resistance. So minus 60 I2, done. Then going to here, plus to minus or minus, but current is in opposite direction, so minus minus plus 30 I1 is equal to 0. Okay, so while solving this, already I1, I2 value already I know, we'll get VTH very easily. Simple only. Simple only. Okay, then to find RTH. Correct? Yeah. So now to find the RTH, here, if I take this junction, current can enter in how many ways? 3 ways. Current can enter in 3 ways. So parallel. 3 or more ways. In a junction, parallel. Else, series. Else it is series. Correct? So 1630 ohm are in parallel and 1614 ohm are again in parallel. So you should know how to do the parallel, and that's it. And once you've done it, you'll get the equivalent resistance. That is RTH. In the sense, once you get both these two things parallel, add these two things, it will become series. I hope you should do it. Okay, 1640 ohm in parallel. Yeah. Then this is my Thevenin's equivalent network. That's all done. Then what I define? The load resistance. So load resistance formula is IL is equal to V by R, right? Correct? I is equal to V by R. So V is already there. R is this plus this. Correct? Yeah. Now in the question you see it. It should be between what? R is equal to 6 ohm, and when the external resistance is what? In the question you come back to the question. And see the question now. It is between 6 ohm and 36 ohms. Simple thing only. R. Already I found out everything. RL, everything I found out. VTH is nothing but R. R is 6 ohms. Then R is 36 ohm. VTH already I know 20. R Thevenins you just now found out 44. Substitute everything in calculator and you'll get it. That's it.